All right. Okay, here's where we left off. So okay, so we're going to do another problem where we use factor theorem to help solve a problem.
Mr. Kyle.
Yeah.
We need help.
What's up?
Is there a recorder? Oh, sorry, I just left on. Never mind, we'll ask him later.
All right, so we're going to use actually, is that one going to work?
Take two.
Okay, so we're going to try and use factor theorem here to see if this works. Okay, so again, you have two options when you're doing this. You can either do polynomial long division or synthetic division. Okay, how many of you prefer polynomial long division right now? Writing out everything. Okay, all right. So we'll do this. We'll do it both ways. So x minus 2, x cubed. Is there an x squared term? No. So what do I have to put in? 0x squared minus x plus 6. So we're good there. Okay. If its highest power is 3, that tells you have to have 4 answers or 4 terms below. Okay. So we start with using long division. What do I take x times to get x cubed? X squared. But then remember, not only do I have to multiply the x squared by the x, which gives me x cubed, I also have to multiply it by the negative 2. So that gives me negative 2x squared, which is why it's really important for you to have that 0 in there. So every power is represented. Then the big thing to remember with long division is, do you add or subtract? Subtract. X cubes will cancel each other out. 0 minus negative 2 becomes 2x squared, positive 2. Minus a negative becomes plus a positive. Okay? And then what do I do now? I have 2 terms out here, so to do division again, how many terms do I have to have on the bottom? 2. So I bring that down. And I start that process over again. What do I take x times to get 2x squared? 2x. So I take 2x times x, which gives me 2x squared. I take 2x times negative 2. That gives me negative 4x. And again, we subtract. What happens to the 2x squareds? They cancel. Then I have negative 1x minus negative 4x. It'd be 3x. Negative 1 minus a negative becomes plus 4. So negative 1 plus 4 is 3. We good there?
Would the x's fall out, does it?
No. No, it's just,
That makes sense.
those are placeholders. Then I bring the 6 down. What do I take x times to get 3x? 3. 3 times x, 3x. Negative 2 times 3 is negative 6. And subtract. So I get remainder 12. So since I get remainder 12, 12 over x minus 2. So is 2 then a factor of that equation? No, it's not. So I can't find all solutions because my remainder is not 0. Everybody with me as to how I got that? Okay. Any questions on that? Good, bad? Good. Okay. All right. Now, if I wanted to do that same problem using synthetic, it's going to be a lot shorter. I put 2 in the box. I got 1, 0, -1, 6. We agree?
Yep. Why 2 in the box?
Because you take the opposite side of whatever you're dividing by. So we're dividing by x minus 2, so you put +2 in the box. I bring the 1 down. 1 times 2 is, and with synthetic, do I subtract or add? Add. 0 plus 2 is 2. 2 times 2 is 4. -1 plus 4 is 3. 3 times 2 is 6. 6 plus 6 is 12. So you get the exact same answer. X squared plus 2x plus 3 plus 12 over x minus 2.
Does that work for every
That
problem?
way makes no sense.
Why?
I kind of like it, I kind of don't.
So this is the remainder. It's after the remainder line. Constant x squared. So what?
Like I like it because it's fast. Easier.
Here? From -x. All right. Okay, last thing in this section. Okay. All right, so finding factors of polynomials. Finding factors of polynomials. Okay, the easiest way to do this is we're going to use what's called P over Q. Okay, the formula is P over Q, where P is your constant, Q is your leading coefficient. P is your constant, Q is your leading coefficient. So if in the problem, let's say I said, well, f of x equals x cubed minus 7x plus 6. And I want to find all factors of that equation. So first off, because what is the degree of that polynomial? 3, which means how many factors are there? 3. Because factors are just the number of possible roots. So there is 3 factors. And it's either going to be 3 real number factors or 1 real number factor with 2 imaginaries. And we don't know what that is until we solve this all the way out. Okay? So we can use P over Q to help us narrow down what are the possible answers for my factors. Because otherwise you're just randomly guessing numbers until you find one that works. And personally, I don't like just randomly guessing because you waste a ton of time looking at numbers that it might not even be. So how you do it? You take, what is my constant in my equation here? 6. And what's my lead coefficient? What's the number out front of x cubed? 1. So my possible factors are, well, what are all the factors of 6 and all the factors of 1? Well, that's 2 pretty easy numbers, right? So 1, it's just plus or minus 1. You can have positive or -1. Okay? What about 6? There's 1, 2, 3, and 6. Positive and negative. So my possible roots here are 1 and -1, 2 and -2, 3 and -3, 6 and -6. So there's 8 possible numbers you may have to test to find factors. The nice thing is, because this is a cubic, you only have to find one that works. Because when we find one, that gets us down to a quadratic. And how do we solve quadratics? Factor, quadratic formula, completing the square, right? Which is why we spent a week talking about solving quadratics. Okay? So, what number do we want to test first of those possibilities?
I would put it in that equation over there.
Yep. Well, you've got 2 options. That's a good question, Jim. You can either do synthetic or you can just direct substitute. My vote and what I think you should do is use synthetic. And I'll show you why here in a second. You can do direct substitution if you want, but then once you find it, using direct substitution, you're either going to have to do long division or synthetic anyway. So why not just do it right away and make your life 10 times easier? Okay? So we want to start with 1. Is that what somebody said?
Yeah.
That's usually what I start with. So I put 1 in the box. Okay? What are my coefficients then? So x cubed is 1. Do I have an x squared term? 0. Do I have an x term? -7. And then 6. I bring 1 down. 1 times 1 is 1. And I add. 0 plus 1 is 1. 1 times 1 is 1. -7 plus 1 is -6. -6 times 1 is -6. And I get a remainder of 0. So is 1 a factor if I get a remainder of 0?
Yeah.
Yes. So that tells me x equals 1 is one of my 3 factors. So how many factors do I have left to find now? 2. Well, what you have left over down here is what's called the depressed polynomial. Okay? It's made smaller. And again, you draw a line from the remainder line. What's that -6 then? Constant. What's 1? And the second one? X squared. So what I have left is x squared plus x minus 6 equals 0. Well, is that a quadratic we can fairly easily solve? Yeah. You have multiple options with what you want to do here. You can either factor that using AC method. You can do quadratic formula. Or if you really like completing the square, you can do that. And I'm guessing most of you are either going to factor or do quadratic formula, right? Okay. Let's try AC here. Just as a good AC practice. We haven't done this in a while. So what is A here? 1. 1 times -6 is -6. I need 2 numbers that multiply to -6 and add to what? 1. 3 and -2, right? Okay. So I replace. I got x squared plus 3x minus 2x minus 6 equals 0. Now what?
X.
Group them. So it'd be x and x plus 3. And those are both negative, so I'm going to pull out -2. And I also get x plus 3. Do my insides match? So I've got x minus 2, x plus 3. So then if I set those both equal to 0, x minus 2 equals 0, that means x equals positive 2. I set x plus 3 equal to 0, x equals -3. 1, 2, 3. So I could ask you, give you an equation and say, find all factors.
So it's x equals plus or -1. Or no, it's just 1.
Nope. So it's just x equals 1, x equals 2, and x equals -3. So we just found all the factors of this equation. Yeah. We want another one of those?
Can you do it the other way though? Not this way.
What'd you ask? 1 second. Yeah, I can do it by long division, yeah. So this is just saying these are all the possibles. So once you find one that works, you can test -1. But the whole key to this, and this is important, so please make sure you're listening. You want to do synthetic and keep finding roots until you get it down to a quadratic. Once you get to a quadratic, you know how to solve quadratics. But if I give you x to the 5th, you don't know how to solve problems to the 4th power. So you keep doing this. So Megan asks, why is this not plus or minus 1? Well, I know 1 works. Could -1 work? I could have tested it to see if it worked. And then you just keep working down. So the nice thing about that, though, is if we would have kept working, we worked just off this depressed polynomial, not back at the beginning. So it gets simpler and simpler and simpler every time we go through each step. So let's actually do one that's a little more complex. So let's look at...
I already know this is a dumb question.
There is no dumb question.
No, it is actually. But like in the box, why does that number, is it always 1?
In the box?
Yeah.
No, that could be any. I always just start with 1. 1's always the first number
But
I
it
use.
has to be one of the factors.
Has to be one of these factors.
Oh,
Yep.
okay. Sorry, I really wasn't following where that
Nope.
was coming from at all.
You're good.
That's kind of like, okay.
Okay?
I don't know.
So this is actually a problem out of the homework, but it asks, this is a good example of what we were just talking about. How many times is 2 a root of x to the 6th minus 9x to the 4th plus 24x squared minus 16 equals 0? Now,
Did a sturdy.
those of you that prefer long division, problems like this going to take a lot longer if you're using long division. This is why problems like this is why synthetic is even a thing. You get much above a 3rd power, it's going to take you 4 to 5 minutes just to do out all that long division, where with synthetic you can do it in 30 seconds to a minute. I know some of you prefer long division, and to be honest, until I started teaching this, I always did long division because I didn't like synthetic. But once I realized how much faster this is.
Synthetic work.
Yes. Yep. Yep. So synthetic is long division, just written differently. They're the exact same process. It's just one.
The 6 and the 1. Why did you do that?
Well, okay. I shouldn't say it works on everything. There is one case synthetic does not work, but for right now, we're not going to worry about it. We'll come back to it later, and we'll talk about that. That's a good question. All right. So it wants to know how many times 2 is a root. And remember we talked about you can get the same answer more than once. Okay? Remember we talked about that with quadratic formula. If your discriminant equaled 0, you got the same answer twice. And we called that a double root. Well, you can have triple roots and 4 quartic roots and quintic roots. Okay? You could end up with the same answer 6 times. It's possible. Probable, probably not, but it's possible. So what we're going to do is we're going to test this. So we're going to put 2 in the box.
How would we write that for long division?
It'd be x minus 2. And then we start x to the 6th has a 1. X to the 5th, there isn't 1, so what do we put in? X to the 4th is -9. X to the 3rd, there isn't 1, so 0. X squared is 24. X, there isn't 1, so 0. And then the remainder, or the constant's -16, so we have our remainder line. Okay. So I bring 1 down. 1 times 2 is 2. And again, with synthetic we add, so that's 2. 2 times 2 is 4. And add, -5. -5 times 2 is -10. And add, -10. -10 times 2 is -20. And add is 4. 4 times 2 is 8. And add is 8. 8 times 2 is 16. And add is 0. So that tells me 2 is a root at least one time. Okay? Everybody good with how I went through that? Now,
When you get x equals 2, is it because 2 is part of your second?
because 2 is the number I put in the box.
Yeah, I know. So you just keep doing it and doing it. Is it because you have 1 and 2 only went down to 1? So you're going to do this again?
No. I'm going to do this again. So what this means is I'm dividing my equation by x minus 2. When I put 2 in the box, that's what I'm dividing.
By x minus 2 until you can't do it anymore, right?
Right. Yep. Now, I'm going to put 2 in the box again. But watch here. This is my remainder. So that's no longer part of my equation. So now my remainder line moves over 1. And I use my depressed polynomial. And I just move the line, my remainder line, over 1 spot. So now I need this to be 0 to keep doing the problem. So if we test it again, 1 comes down. 1 times 2 is 2. And add is 4.
Whoa. That was super.
Sorry.
Okay, so.
Why does x equal 2?
Here,
Yeah.
because it's asking how many times 2 is a root. So in the problem, it gave me that 2 is going to be a root. So I put 2 in the box because I'm dividing the whole thing by x minus 2 to make sure that I get 0 as a remainder. To make sure it goes in evenly.
Okay, so
And if it does go in evenly, say what?
If you got 0, then it's x equals 2.
Yep. And now I'm repeating that again to see, do I get x equals 2 twice? Okay. 4 times 2 is 8, so that's 3. 3 times 2 is 6. Negative 4 times 2 is negative 8. And add is negative 4. Negative 8, and you get 0 there. So that means I get x equals 2 a second time. Now we try it again. So I put,
Oh, you do it.
huh? So I move.
Do that forever.
I move it over again. We do it until it doesn't work. So if I do it again, 1, 2, 6, 12, 15, 30, 26, 52, and I get 48 as a remainder. So the question asks, how many times does it work? The answer is 2, which means we still have a 4th power polynomial. We have to figure out how in the heck are we going to solve that. And at that point in time, you would have to be able to factor it. For what we're doing right now, we're not to that point yet. So the goal of this, if I was to give you a 6th power problem, is you keep trying numbers until you get it down to a quadratic. Is 2 the only one we could try? That's the only number we tried. So our factors of 16, we could try 1, negative 1, 2, negative 2, 4, negative 4, 8, negative 8, 16, negative 16. Now, we're not going to do that right now because all I asked for in the problem was how many times is 2 a root, and that answer is twice. But there is still 4 more answers we would need to find if I asked you to find all 6.
But that's how you do it. You just do like a certain number.
Why only the 16?
Because we're using our P over Q rule. So you take the constant, 16, and divide it by the lead coefficient 1, and you write out all the possible factors of that, whole number factors.
So you know how many factors there are based on what the leading thing is?
Total, yes. So since the degree there is 6, that tells you I should have 6 possible answers. Yep. Any other questions on this before I give you your homework on 3-3 or 4-3?
No.
All right. Here we go. Synthetic? If you prefer long division, I don't really care.
Where's my bad?
So can we do synthetic for all these problems?
Yeah.
Let's get like 2 for all. Yeah.
That's it.
That's it. He said.
Well, there's only
Okay. So just so you're aware what you have coming the rest of the week here. So this is the end of 4-3. I told you you would have a quiz after section 3. So tomorrow I will take questions on the homework. We'll review sections 1, 2, and 3. And right now my plan is to give you a quiz over sections 1 through 3 on Thursday.
And then Friday we'll have off.
Okay? Which means we're going back to defining polynomials, talking about degree, lead coefficient. Okay? Section 2 was quadratics, so completing the squared, quadratic formula, factoring. And then section 3 using rational root theorem, which is synthetic division to simplify.